A couple of announcements for today. Hold on, I just need to scroll to find them. There we go. So, a couple of reminders. We have sent out a midway feedback form for you all to fill out. That is worth 50 Ignite points, so please do check your emails that you signed up with for that. Go fill that out. It's for us to know how you guys are feeling about the program so far. Additionally, we have our end of semester gala, and that will be on December 10th from 6 p.m. to 8 p.m. And we have confirmed that representative from Google will be there. So we do hope that you all will attend, and a form for that was sent out earlier today. So please go check that out as well. Nobody said that there's any audio issues, so unless I hear otherwise, we will get started on today's content. So today, there we go, we're going to talk about loops some more. So last time we talked about for loops, and we went kind of over those with the context of lists, where we're iterating over each item in a list. Today we're going to talk about for in range loops, which are a little bit different, but work much the same. Then we're going to talk about while loops, which are, they're different in a couple of significant ways. So that will be some interesting stuff for us to go over. We're going to talk about getting inputs, and then we're going to go over some examples. So we're going to continue on with our discussion from last time about loops. So if you recall last time, we'd had the for loop, which goes over each element in a list. But sometimes we don't really want to deal with an entire list. We want to deal with a bunch of sequential numbers. And for that, we have range. So range gives us a list of numbers that starts at 0 and goes up by 1 to 1 less than the number you give it. So in this example, where we have range 9, that corresponds to the list 0, 1, 2, 3, 4, 5, 6, 7, 8. So it stops at 1 less than the number we put in. And that might seem a bit weird, but if you count up the number of elements in here, there's 9 elements in there. So you can think of it as being the first 9 numbers starting at 0. We can also use variables in range, and so that lets us make this, this list of the first however many numbers go for the first few numbers. We don't necessarily need to know when we start writing our code how many that is, and that can change over time. So here we say random numbers equals 20, 100, 5, 60, and then we say x equals len of random numbers. So we set the variable x to be the length of the random numbers list. In this case, that's 4. Then we say range x, and that corresponds to the list that starts at 0 and has the first 4 numbers in it. So 0, 1, 2, 3. This is really convenient for us if we want to repeat some code a specified number of times, as you can see here. So if we wanted to print high 3 times, we could write for I in range 3, print high. And you see we don't even use I here. I don't recall if we talked about this last time. I is a kind of programmer shorthand for iterator, which is a technical term for the thing that changes. So pretty much for I in whatever means just for each thing. It's the same as for item or for index. All of those things mean pretty much the same thing, and programmers are lazy. So we want to write as few letters as possible, and we picked I. Let's do a quick example of this, and we can also check and see if my coding window is working. So as always, we're going to start with import Spark, then reload extension, Spark, and I forgot to put a % sign at the front of this, so let's go back and do that real quick. Whoops. We'll run that to get Spark started, and then we'll say % ignite, redef setup for I in range 3, print high. And if we run that, we see it prints high 3 times, exactly like we would expect. You will also In this view, notice a slight difference in how I'm displaying the presentation and the code. So I do hope that that's not too distracting for you all to have the border there, but this is far more convenient on my end for doing the recordings and stuff. Okay. Oops. Let's switch back to the presentation. There we go. And back to the presentation here as well. So one of the other really useful ways that we can use range is using range with loops and a few different lists, because we can use I as an index, like I mentioned, to access values from lists. So you remember, if we want to get the first element in numbers, we use the index 0. And that means we skip over 0 things. If we want to get the second element, we use numbers at 1. And that gives us 9 in this case, because we skip over 1 item. So when we iterate over numbers at I, as you see here, so we have for I in range 3, that means 0, 1, 2, print numbers at I. So that will iterate with I equals 1, and it'll print numbers at, it'll iterate I equals 0, print numbers at 0, which is 4. Then it'll print numbers at 1 the next time, and that's 9. Then it'll print numbers at 2, and that's 16. And so what we expect to see from this code is 4, 9, 16. We will once again just quickly switch over to here to show that off. So we'll set up a list numbers that'll be equal to 4, 9, 16. For I in range 3, we will print numbers at I. And so you can see the first time through, it prints 4, which is numbers at 0, then 9, numbers at 1, 16, which is numbers at 2. I don't want to belabor the point, but it is a little bit complicated, so we do want to make sure everybody gets that. And again, as always, if you have any questions, feel free to ask either in the chat or the Discord, or just ask your mentors when we go to breakout rooms. So we can use this method of iterating over lists to work with multiple lists. So if we have, for example, balls and sizes, which describe the position and size of multiple different balls, then we can use this for I in range whatever to get both the ball position and its size using the same variable, the same iterator. So you can see we have here for I in range 4, circle balls at I, sizes at I. So that will start with 0, and so it'll do circle balls at 0, which is 40, balls at 0, still 40, sizes at 0, which is 10. So that will draw just in from the top left a small circle. And I don't want to explain that all in detail, so we're going to switch back over to coding, and I will demonstrate that again real quick. Also going to slightly size up the presentation in the bottom corner there. There we go. Okay. So we will say balls equals 40, 100, 180, 260. Sizes equals 10, 20, 30, 40. Then we will say for I in range 4, circle balls at I, balls at I, and sizes at I. So the first time through, that'll use 40 and 10, then 100 and 180, then the other ones as we go through. I did not make that big enough to show, so let's do a quick size 500 in each direction should do. So you can see we go from the top left and we go further and further in, and the balls get slowly bigger and bigger. So that's one of the very useful ways that we can use range with our for iterator, with our for loop. Here's another example. This may look familiar. This is one of the things that we were working with last time, where we had these kind of blue bars that went across the screen. So you can see here we have the Y positions in a list and the blueness of these bars in another list. And then we say for I in range 4, so we're iterating 0, 1, 2, 3. We want to fill style 0, 0 blue list at I, so get the appropriate color and fill with that. Then draw a rectangle at 0, so the left side is at the left side of the canvas. Then we get the Y position, and then our width is mouse X, and our height is 30. And once again, we will quickly demo this. We'll say, size 500, 500. Y list equals 50, 130, 275, whoops, 400. Blue list equals 255, 180, 120, 75. Then we will say for I in range 4, fill style, no red, no green, and blue list at I is our blueness. And we'll draw our rectangle, starts at 0x, and the appropriate Y position, so Y list at I, and its width is mouse X, and its height is 30. And the last thing that we need to do in here to make sure that we get something that looks like what we see on the slideshow is to put in a background. So we'll do background yellow. So if we run that, we can see that works exactly as expected. We get bluer as we go down, and also the bars are at the different positions. And that brings us to exercise 1 for the evening. So we would like you all to make 6 different raindrops that will fall down with all different speeds. And so those should use 3 lists, 1 to store the X position, 1 to store the Y position, and 1 to store the speed. And we would like the, as a bonus, you can make the raindrops jump back up to the top and fall again when they hit the bottom, as you can see going on there. You don't need to do the cloud, but if you feel like it, please, and you have the kind of spare time, go for it. So we will go to our breakout rooms now. Okay, looks like we've got just about everybody back. So we will continue onward. But first we're going to briefly go over how one might do this exercise. So I am not going to do the clouds because that's more than I want to do for a quick demo here. We'll do %% ignite, def setup, size 400 400 is kind of our standard template, and def draw as usual. And then what we will do is we'll draw a background. So we'll say background is in blue. And then we know that we want to have three lists. One that corresponds to the X positions of our individual raindrops, one that corresponds to the Y positions, and one that corresponds to their speeds. So we're going to set those lists up. And because we know we want at least some of those to change over time, we're just going to make them all global for the sake of convenience. So we will say X list is equal to, let's start it at 100. Let's do maybe 160 and 200 and maybe 340 and 400 and 435. I don't know, some numbers. And we'll start all of these raindrops at the same Y position, because why not? So 6 zeros. And then we will make the speed list. And let's make the left one pretty slow at 1. We'll make the next one something like 3. We'll have a 2. We'll have a 4. Then maybe we'll have another 1. And maybe we'll have a super fast one with a 6. So what we're going to do is then iterate over each of these. And for each one of these, we're going to want to do pretty much the same thing that we would do normally to have a block move down the screen. And then possibly go back to the top. But I'm just going to do the basic and leave the rest to you. So we're going to say for I in range 6, because we have 6 items. We're going to draw a rectangle. Well, let's also change our fill style. So we'll say fill style is gray. And we will draw a rectangle at X position, X list at I, and Y position, Y list at I. We'll give it a width of, say, 20 and a height of, say, 40. I don't know, some numbers. Then we're going to make the Y value change over time. And one thing that some of you may have noticed I forgot is the global statement right up at the top of the draw. So we'll say global X list, Y list, and speed list. So we're then going to say Y list at I plus equals speed, speed underscore list at I. And when we draw that, we see that we get some rectangles moving down the screen. And I think the reason that we're only seeing 4 of them is because I put a few of them outside the boundary of my screen. That'll do it. We'll make that 500 by 500 instead. Oh, dang it. There we go. So you can see we have 6 things that move down. And you can extrapolate from there to how you might do the bonus challenge of making them fall back to the jump back to the beginning and continue falling when they hit the bottom. But for the moment, we will continue on with our presentation. Now we're going to talk about a totally different kind of loop. So thus far we've been talking about the for loop, and that lets us iterate through a list, whether that's a list of items like we had last day, or the list of the first however many numbers like we were working with today. We're iterating over a list. Today, we're also going to talk about another kind of loop, and this loop is called the while loop. While loops act a bit more like if statements. They will check if something is true, and as long as it is true, it will keep running the same code over and over again. It's a bit like taking a walk in the rain. So when you go walking in the rain, you start walking in the rain, And as long as it is raining, so while it is raining, you keep your umbrella up. Once it stops raining, you put away your umbrella. But that middle step 4 is the while loop that we would have here. And because we don't know how long it'll rain for, but we do know, we can't use a for loop. We couldn't say for seconds in 1 to 1,000, right? We don't know that the rainstorm would end after 1,000 seconds. But we do know that we want to have our umbrella up as long as it's raining, and for that we would want something like a while loop. So we will continue onwards. So how do we use them? This is a simple example of a while loop. So this just counts to 10. So we start by saying I equals 0, and then we check to see while I not equal to 10. Remember from one of our previous lectures that the exclamation point equals means not equals. So while I is not equal to 10, we want to print I, and then I plus equals 1. So we increase I by 1. So that will run as long as I is not equal to 10. We will do a quick demonstration of that. So we say I equals 0, while I is not equal to 10, print I plus equals 1. Dang it. So you can see it starts with I equal to 0, and then until I is equal to 10, it keeps running, and once I is equal to 10, it stops. So it stops at that point, and we don't ever print 10. So what would happen if we removed the line I plus equals 1? Well, we would start by saying I equals 0, then we check to see if I is equal to 10, and 0 is not equal to 10, so we print 0. And then we don't do anything else, so then we check to see if I is not equal to 10. Well, I is still 0, and 0 is not equal to 10, so we print 0. And then we don't do anything else, and then we go back to the top, and we check to see if 0 is not equal to 10. And you might be able to see this is going to cause us a problem, because I is never going to change. So I is always going to be not equal to 10. And this is going to mean that we print zeros until the computer crashes, until it stops. So I'm going to demonstrate that and then kill the kernel, but generally you do want to avoid this. It causes some problems with the platform at the moment. So I'm going to say %ignite. We will say I equals 0, while I is not equal to 10, print I. We will have the commented line I plus equals 1. And if we run this, we can see it actually totally breaks, because the way that our print statement works is it expects something to end at some point, and it never does. So I had to hit the stop button to get it to stop, and I'm actually also just going to restart my kernel, because there's some weirdness that goes on behind the scenes if we don't do that. But yeah, that's what we call an infinite loop, and they're generally considered to be not great, because generally you don't want to do the same thing forever with nothing ever changing. You want to change things over time. That's kind of what makes programming useful, is that you can do things with changing values, or you can change values yourself. So infinite loops are generally not particularly useful, but while loops overall can be. So we will continue on to our quick question. So taking our previous example and changing it to add 3 to I every time instead of 1, what happens and why? And I believe we have a poll for that. And as usual, we will give you about 1.5 minutes to answer this. So you have about 45 seconds left. And now about 15 seconds. And that's pretty much time. So the correct answer is not positive we have this poll with the correct answer. The correct answer should be that this is an infinite loop, because we start with I equal to 0, then as long as I is not equal to 10, we print I and then add 3 to it. So we're going to start with 0, and then we will print 0, and then we'll increment it by 3, so it'll print 3. And then 3 is not equal to 10, so we'll run again, and we'll print 3, and then increment it by 3, we'll have 6. 6 is not equal to 10, so we'll print 6, and then I plus equals 3, so it's now 9. 9 is not equal to 10, so we'll print 9, and then increment it by 3, and now we're at 12, and uh-oh, we've already skipped past 10, but we're still not equal to 10. So we skipped straight over the point where we wanted it to be our endpoint. So this is an infinite loop, and it's a little bit more subtle than the previous one, because we do still have this condition for the I plus equals 3, but it doesn't ever actually match our ending condition that we really want. So one of the questions people often ask at this point is, how are while loops useful? Why would I ever want to use these? And the general answer is that they're very useful when you don't know, or you don't know how many times you want to repeat a given section of code, right? Like in our umbrella example, where we don't know how long we want our umbrella to be up for. We just know that as long as some condition is true, we want our umbrella to be up. So that's what while loops are useful for. In comparison, for loops always require us to know how many times we want to repeat the code, whether that's by iterating directly over the list, or whether that's by iterating over a number that corresponds to how many items we have in the list. And for loops only repeat as many times as you tell them to. But while loops repeat until a condition is false. So in our previous examples, it's been the condition I not equal to 10. So these loops would repeat until that condition is false. In the umbrella example, it would be it is raining, would be the condition that we're waiting to be false. Both of these let us repeat code multiple times over and over again, and both of them let us use multiple lists. Oops. There we go. So here's an example of using a while loop to do something slightly more productive than we've been doing so far. So we start by setting x equal to 50, and then we say, well, x is less than mouse x. We want to draw a circle at x, and at x position x, with y position 250, and with a size of 10. And then we say x plus equals 20, so we then move rightwards by 20. And this corresponds to drawing a line of dots that starts at x position 50 and goes rightwards to wherever our mouse is. And while we do have the GIF there, we will just do a quick demonstration to show that that does in fact work. This will need def setup and draw. So we say size 400, 400, def draw. We'll draw our background in pink. And then we will say x equals 50, while x is less than mouse x, circle x 250, 10, so x position x, y position 250 with a diameter of 10, and x plus equals 20, so move 20 to the right. And if I run that, you can see that as I move my mouse around, the program draws dots up to where my mouse is on the screen. which actually takes us to exercise number 2. So here we're going to want you guys to use a while loop to build this sort of pyramid structure that we have. And so in a similar fashion to how we were just drawing the dots, you want to start with a variable y equals 0 and use it to make your while loop condition. And so once again, we will go to our breakout rooms so that you guys can work on this. Okay, once again, it seems like we have just about everybody back. I do apologize also, we are running a little bit late this evening, so the next bits will be a little bit more hurried than I might have liked, but I do hope you all can still get something good from it. We will still briefly go over this code here. So I'm actually just going to copy and paste our entire code for the dots, and we will then go to another cell. What we will do here is we're going to make our background a light yellow, so we'll start with 255 red, 255 green, and let's say 180 blue, and that'll correspond to a very light yellow. Then we're going to make y equal to 0, and so that's going to correspond to our kind of starting point at the top being 0. Then we're going to say, while y is less than mouse y, now we're going to draw a rectangle. And so here what we're going to do is we're going to draw a rectangle. I did forget my fill statement. So let's also quickly add that in. I'm just going to fill in red. So we will say fill style is going to be red, or we can even say orange. There we go. So we're then going to draw a rectangle. We're going to say its x position is about 5, based on that the image we have there. Our y position, let's make it y plus 5. That'll give us a little bit of spacing from the top. And then our width, well, what's our width going to be? Let's make it 10 plus y times 40. What that lets us do is, as we go further down, in fact, we don't want that. We just want 10 plus y because we're moving down quite a lot. So as we move down, our kind of however far we've moved down, we also add that to our width. And so as we go further down, the bars will get wider and wider. But then our height is just going to be something like 30. And then, because we've made our height 30, and we would like to have, let's say, spacing of about 10, we'll say y plus equals 40. And so if we run that, we get nothing, because I turned off my kernel. 1 second, everyone. Sorry about that. There we go. Now if we run that, you can see that as I move my mouse up and down, we get more or less bars depending on where my mouse is. And they get wider as we go down. So let's talk about the last bit of content we have regarding loops. We have the keywords break and continue, and this changes how loops flow. So typically, a loop flow just goes from the top to the bottom, back to the top. If there's still more it needs to do, it goes through again. If there isn't, it goes past it and to whatever comes next. But we can use the keywords break and continue to change a bit how that works. Break ends the loop immediately. And so if we were in a while loop and we type break, that will break out and take us back to our sort of regular code flow. Continue skips the rest of the current iteration through and goes to the next one. So most of the time you're going to be using these with an if statement, because otherwise it's not particularly useful, because when you if you tried to use this without an if statement, you would just have break or continue, and that would just either make your loop totally useless or make anything coming after the continue in your loop totally useless. That's the window. There we go. So we can see here how we expect it to work. So break stops the entire loop. So on the left we have for nums equals 101, 202, 303, 404. We're saying for n in nums. We say if n is equal to 303, break. And then if we haven't broken out, we'll print n. And so what that will do for us is print 101, then it will print 202, and then it will n will be 303. It will see that that is equal to 303, and it will break. So it won't finish that loop. It just goes straight out to after the loop. and so that will then print done. On the right, you can see continue, and that will just skip the rest of the current item. So we would see 101, 202, then when it got to 303, we would check and we would see n is equal to 303, and then we continue. We just skip the rest of this this go round and then go to the next one. So we would then print 404, and then we would be done. Again, because we're running a bit late, I am not going to do that one on JupyterLab. You can do that yourselves. It's fairly straightforward. The next thing we're talking about today is inputs, and this is the last thing we're talking about as well. So brief review, we talked about mouse is pressed, and that's a variable, a Boolean variable, that is true if either mouse button is currently pressed. And so we can use that to detect mouse input. So you can see an example here where we do our kind of setup, and then we say in def draw, if mouse is pressed, then we draw a circle at our current position. And so that lets us kind of draw using our mouse, because every frame it checks to see if mouse is pressed, and if it is, then it draws another circle. And because we never redraw the background, all of those circles just stick around. Again, you can try that yourself. That's something we've done before, so we will continue on. This is new to us, though. These are keyboard inputs. So we can check if a keyboard button is being pressed down using the method keys held. So keys held at A is true when the A key is held down. Keys held with Z is true when the Z key is pressed down. So you should make sure to use lowercase letters for that. There's a few bits of weirdness surrounding that, but pretty much if you use lowercase letters, it will almost always work. So here's an example. So we have if keys held G is true, then we will fill style green, else we will fill style with white. And then we'll draw a square at 50, 50, 300. That text in the middle will not show up if you just copied this code. But if we switch over to here, I'm going to say def setup. Whoops, I forgot up at the top, %% ignite. So def setup, we'll say size 400, 400. Def draw, oops. And in here, we will draw our background in black. And we will say if keys held G equals true, then we will fill style with green, else, whoops, else, we need to make sure that lines up correctly, fill style white. And then we will draw a square at 50 and 50 with a size of 300. And then afterwards, we'll write in our text. So we'll say fill style white, and then we'll draw our text, and we'll say text, and that will be at something like x 100, 200, and the text is key G is held. So if we run that, you can see when I hold G, the square turns green, and we can see our text, but when I let go of it, it turns back to white. So quick question number 2. These two pieces of code here do the same thing. So from this, we should be able to deduce the type of keys held at G. And the question is, what is the type? So a poll should be popping up for that. And we will give you about a minute for that one. make sure to get your answers in. Got about we'll go to the standard minute and a half, so about 30 seconds left. Ten seconds remaining. And that's just about time. So, most of you got the correct answer, and that is that the type is a Boolean. So even though we have a string in there, where G here is our string, the type of keys held, G, is a Boolean, because we can compare it to true, and sometimes that will be the case. If it was a string, that wouldn't be true. That wouldn't be the case. We can never have a string be equal to the Boolean true. It's a bit like how range of 5 isn't an int, it's a list. Okay. So another thing that we can do with the keyboard is check to see what key was most recently pressed or released. So the computer remembers the last key event, and it stores that in a special variable called key. So if you press the letter A on your keyboard, then key would be equal to A. If you release the letter Z on your keyboard, then the key would be equal to Z. And so if you press both A and Z, then release Z, it would be Z, even if you pressed Z, A, and then release Z. So it's not which key was most recently pressed, it's what key most recently did something. So here's an example of that. I will put this one in and just demonstrate a bit what I mean. So we will switch over to coding again. $% ignite. Def setup. Size 300. Def draw. Background is green. We'll say text size of 48. Text align center. That just tells the computer how it should align the text on the kind of coordinates we give it. And we'll say text key 150, 150. So if we run that, we see that as I press keys on my keyboard, we get letters popping up. So if I press A, B, whoops. One thing that I did forget to mention when working with these key variables is there's a little bit of a quirk in how it works, and that's that your mouse needs to be over your drawing. So if I press A, B, C, and now I release B, it flashed to B there in the middle, and that's because I released B. But you know how if you press and hold the C key, it'll type C over and over again? That's pretty much what happens there as well. But you can see that as you press different keys, you get all of the different keys popping up here in the key variable. Okay. That brings us to exercise 3. I think for the sake of time, I'm going to temporarily skip over this and we'll cover the last bit of content that we have, and then we will go to our final breakout rooms for you guys to work on exercise 3 and have your kind of end of session time with your mentors to ask any final questions that you have as well. So the last bits of content that we would want to talk about today are random numbers. And random numbers can be super useful in all sorts of circumstances. So, I mean, in all sorts of games you have random numbers. They dictate how, enemies move or how items move around on the screen, all sorts of different things. So we have two things that give us random numbers. We have random with no arguments, and that gives us a random decimal or floating point number between 0 and 1. We have randint, and that takes one argument. That should be an integer. And that gives us a random number between 0 and whatever number we give it. So If we did rand int 10, that'll give us a random number between 0 and 10. And 0 is possible, but 10 is not in those cases, I believe, is how we've set that up. A quick example of how to use that is we have this little bit of code here. So we have if mouse is pressed, then we generate a random diameter, and that diameter is rand int 50 plus 25. And then we'll draw a circle at whatever our current mouse position is with whatever random diameter we just generated. And so by using rand int 50 plus 25, that gives us a range from 25 to 75, because if rand int 50 gives us 0, that's 25 overall, and if it gave us 50, that would be 75 overall. And because we're pretty much going to call this the end of our content for the day, we have also our exercises. So I'll go back to our exercise 3 for the session, but these are the weekly exercises for you guys to work on. So the Bug Busters one, you can see over on the left, we have a sort of painting program where you can use the keys to change the color of your notional paintbrush. And then on the right, we have a program where you have squares which change their color over time through shades of blue. The Pythonic Lava exercises we have on the left. The name here is Ball Bonanza, so as long as your mouse is pressed, it should generate balls moving in a random direction and with a random color. And on the right, we have a water fountain, and so you should be able to control the direction of those balls using the keyboard, or I guess in this case the water droplets. And at this point, we're also going to remind you that in sessions in 8, you guys will be making your own game. So you can make whatever game you would like, and your mentors will be there to help you guys out. We do recommend thinking about that, or starting to think about that now, because it makes it much easier later in the process. We have some inspiration for you here. So with that, I will send us back to exercise 3, where we are drawing a circle and controlling it with the WASD keys. So W moves up, S moves down, A moves left, and D moves right. And we will send you guys all to your breakout rooms again to work on that, the end of session exercises, and you guys can start throwing around some ideas with your mentors. So, I'm not quite sure if we've got everybody back yet. I see. Okay. Alrighty. Well, it looks like we've got most everybody back who's going to come back. So, to those of you who stuck around to the end, thank you very much for joining us this evening. I apologize for the kind of hurried nature of the last little bit of information there. I hope despite that you all had fun, you all managed to learn something, and we will see you all next week. So, thank you all once more for coming. Cheers. Have a good evening.